Meteorite activity where we're making craters, and a reminder that you can see more on the Smithsonian Learning Lab site under meteorites. And so with the cratering activity here on Boredom Busters, you're looking at the far side of the moon. Strangely enough, there's only one face of the moon that we see all the time. And what you're going to do in the cratering activity, you need some of these materials. 3 rocks or more, difference in size, and if you number them, it helps you repeat things and know what was happening. And then this big tray, an aluminum tray. It could be a large cereal box with just the top flat face cut away. Some flour or some sand, so that you've got a bit over an inch of a layer on the bottom of your container, and then some cocoa powder or a different coloured material so you can actually see the impacts better. Protractor if you're going to measure angles, a meter ruler, meter stick, or any stick with markings that you put on every 10 centimetres, a smaller ruler, and a piece of cardboard that really you're just going to use to smooth, flatten after each of your tests, and have a large plastic bag so you can clean up. And here we're just looking at some craters, and these are on Ganymede, Jupiter's largest moon. And as with any activity you do, some safety, some adult supervision, good to have some eyewear, glasses, and surround everything you do with newspaper or plastic, because it could get messy. And here are some craters on Mercury. There's a double crater there. How do you think this happened? And when you do the activity, are you going to make a double crater? And look more closely, what else can you see in that double crater there? And so step 1, put flour or sand at the bottom of the container, an even layer, and you can use cardboard to smooth it out. Put a very thin layer of cocoa on the top. Number 1, it's expensive. The other one is for the experiment. You just want to see what happens to the surface layer and what's underneath it. And then you're going to measure the biggest width of, well, all your rocks, but one of them, and hold it 50 centimetres above the surface of the material in your tray. You're going to take the meter stick away, let the rock drop from that height, just under gravity, no extra force, and let any powder settle. And then you're going to carefully remove the rock and draw the impact crater, the ejector pattern, the spray pattern, and actually do some measuring. So diameter of impact, and it may be slightly different in different directions, depth, number of rays, how you would describe the flour or sand and cocoa, length of each ray. And so after you've done the first test and written stuff down, smooth it down again with your cardboard. You might need to add a little more cocoa before each trial, and try a different size rock. Drop from the same height. And you can do that with several rocks. And then look at your measurements and decide, what does that tell you about the size of the rock and the cratering that it formed? And if we're going to look elsewhere in the solar system, can you extend what you've just discovered about craters of different sizes? And here you've got an asteroid, some satellites, moons, and a couple of planets as well. So you've just investigated changing the size of the rock. So if you continue repeating it with one rock only, but you're going to change something else, what would this do to the crater size, the ejector, the spray size? So write down what variable you changed and predict what you think would happen as you repeat the experiment. Now, here I've put height of drop, so you could change the height of drop. Angle of drop, if you've got a protractor, you can measure it, otherwise estimate it. And tilt the tray as you drop it. Force, so you're not absolutely going to hurl it down into the tray, but add a little bit of force rather than just releasing it. And you've got space for your dimensions there. And what does that tell you about craters at different angles? What does that tell you about craters from different heights, or the force of the crater? Now, this is Meteor Crater in Arizona. And what made that big hole? And here are some dimensions here. It's 170 meters, over 500 feet deep. It's 1,200 meters in diameter, nearly 4,000 feet. It's huge. And the rim rises 45 meters, nearly 150 feet above the surrounding ground. And you can see some leftover ejecta there as well. So what happened to the meteorite that made that crater? And here's a surface view. Now, it also, in the same scale, shows the size of the meteorite. A 50-meter wide meteorite made a 1,200 meter hole. And nickel iron meteorite that was about 50,000 years ago. And what happened to the meteorite? Half of it that was incoming burned up in space. Burned up on entry to the Earth's atmosphere. And the rest of it vaporized on impact. And you can actually see a fragment of the actual Meteor Crater meteorite that hadn't quite vaporized, obviously. And this is known that it has thumbprints, and quite a few of the iron meteorites, the metal meteorites, actually have what are called thumbprints all over it, regmaglyphs, caused by it melting and the force as the meteoroid entered the atmosphere. And as it glows, that's a meteor, hits the ground, it's a meteorite. And let's just look at the steps involved. So we've got the meteorite hitting, and a shock wave, ejecta, heat and pressure melts the material and ejects it even further. And that's sort of the excavation stage. And then it goes on to a modification stage with a central uplift forming a central peak, which in the course of the movement of the ground underneath it then disperses a bit, but you can still sometimes see different numbers of peaks. And here's an impact crater, which was pictures taken by NASA's Galileo probe, Europa, one of Jupiter's moons. And why is it dark? Why do you think you can see the crater is dark, the ejecta material around it is dark? And then another question, we've got not quite the blue marble, but nearly of Earth seen from space. Incredible picture. Other solar system bodies have craters. Whereabouts is the cratering on Earth, and where do you think they have gone? So some things to think about. And again, you can go to the Smithsonian Institute SI Learning Lab Touch a Falling Star resources to investigate meteorites and other activities.